This video will demonstrate how to prepare a custom transportation network for use in the Freight and Fuel Transportation Optimization Tool, or FTOT. This video assumes that you have already downloaded and installed FTOT, as well as the supplementary data and documentation. These materials are available on the FTOT landing page. You can also take a look at our Installing FTOT tutorial video linked in the video notes alongside other resources for this tutorial. FTOT relies on a network geodatabase for attributes that are used to optimize routing and flows during scenario analyses. The supplementary data includes a default multimodal network spanning the continental United States, which is recommended for use with national or regional scenarios in the US. FTOT's technical documentation goes into more details on how the default US network was constructed. However, if you're looking to run a non-US scenario, or a more local use scenario, or use a more detailed or tailored modal network, you can use a custom network in FTOT. The specific optimal routing solution found by FTOT depends on the comprehensiveness and granularity of the network used. We recommend matching the scale of your custom network to the level of accuracy desired in reporting, particularly around first mile, last mile results. In this video, we'll start by providing some background information on network data and requirements in FTOT, and then we'll demonstrate how to update a network feature dataset to follow FTOT's required schema, and we'll show what to update within your scenario files. We'll demonstrate this with an example road network and show how to run the Quick Start 1 scenario on our new custom network. Note that this tutorial will use ArcGIS Pro, which is one of FTOT's software dependencies, and prior experience with ArcGIS Pro is highly encouraged when preparing your network for use in FTOT. Let's begin by taking a closer look at what's available in the supplementary FTOT materials. Right now, I'm in the top level FTOT directory, which is also where I've saved the scenarios and documentation folders. Let's go into scenarios and then into common_data. The common data folder contains a variety of files, many of which are required for FTOT, and some of which can be replaced by your custom data. For example, this folder contains the Tableau dashboard template file. FTOT always looks for this file when generating reports. Then we also have here the default facilities data, which contain representative points for raw material producers, processors, and ultimate destinations in every county, specifically at the centroid of the most populated place in those counties. You may wish to bring your own facility location data, and FTOT's user guide walks through a few different options to do that. For this demo, we're going to focus on the network and accompanying inputs. The geodatabase with FTOT's default network lives in this networks subfolder. There's one main network, and then a second network for users who want to run scenarios considering background flows and vehicle capacity on roads. The GIS data inside geodatabases can only be interacted with through GIS software like ArcGIS Pro. There are also these two CSV files. The impedance weights file is used to adjust the cost of using different link types, for example, to incentivize flows over highways rather than local roads. The impedances CSV is optional, but highly encouraged, and in a few minutes, we'll create a copy of this and update it for our custom network. Then the detailed emission factors CSV is also not required unless you are running a scenario with detailed emissions calculations enabled. There's more information on both of these files in the FTOT documentation. The user guide provides more detailed information for anyone preparing and using a custom network. In the section on advanced scenario options, there is a subsection on customizing the FTOT GIS network, and then specifically on creating a custom network. This section walks through 4 high-level requirements for any custom network. At a high level, your network should include your modes of interest in a meters-based coordinate system and be connected and routable. You'll also need a set of intermodal facilities to move among modes if you're including more than one mode. I'll explain each of these 4 requirements in a bit more detail. First, any modal network must be saved as a distinct feature class within a single geodatabase and within a feature dataset named network. Second, each feature class must use the same meters-based coordinate system, which you can confirm by looking at the spatial reference in the feature class properties. Third, all features should be fully connected and routable, meaning that lines in the network must be split at all intersections. Finally, intermodal facilities can enable commodities to shift between modes while in transit from one facility to the next. Intermodal facilities must be a point feature class within the network dataset, and the relevant modal networks should have artificially created links leading to those facilities. The user guide explains how to manually add and connect intermodal facilities. Beyond those requirements, Appendix B in the user guide also outlines the schema that each network feature class should follow. This appendix contains tables for each mode, and then lists the attribute names that should exist in the feature class and what type of information those attributes should provide. For anyone trying to confirm their network meets these requirements, FTOT includes a supplementary tool that performs some preliminary checks on the network dataset with just a drag and drop of the GDB file. See the user guide for information on running this tool and other FTOT tools. For this tutorial, we will run Quick Start 1 on a custom network adapted for FTOT. Our starting network will be a detailed road network prepared by the Massachusetts Department of Transportation and downloadable from their public GIS repository. First, let's connect to the GDB with that starter network. So I've already connected to the common data folder within ArcGIS Pro. I'm going to open this, and I have saved mass.roads.gdb within my networks folder for convenience. So if we open this GDB, we see these 3 different feature classes with the 3 road networks that mass.dot publishes. These are in with varying levels of detail. We are going to use EOT roads_arc. So let's add this to the map. We can see this is a very detailed road network. All right, now we're going to prepare this for FTOT. So let's minimize these. So first, we're going to create a new file, geodatabase, and we're going to save this within our common data folder. We're going to save it in networks. And I'm going to call this custom network.gdb. And ultimately, we will update our FTOT scenario to point to this geodatabase. So let's save. Okay, so we see it's here. And now we're going to create a data set within this GDB, feature data set, and we're going to call this feature data set network. For the coordinate system, we're going to use what's already populated here. This is the same as in our source data set, and we already know that this is meters based. If your source data sets for the different modes are in different coordinate systems, you'll want to project those data sets into a consistent coordinate system ahead of this step. We're going to run this. Great. Feature data set has been completed, and there it is. Right now, there's nothing in it, though. So we're going to export this layer to a new feature class within our network dataset. So input features, the output feature class. I'm going to go to our common data folder. We can see our new geodatabase. We're going to double click this and double click the network dataset. And we're going to call this feature class road, which is what all road networks in FTOT must be called. Save. Click OK, and this will export. So our features have finished exporting. We can see a second layer has been added to this map. It's called road. Let's remove our original network so we don't get confused. Now let's open the attribute table for our road network. And we can also see here that this road feature class has been saved within our custom network GDB. So this table lists all of the available attributes within this network. We jump back to our schema and we look at the table for road. We see that there are a handful of required fields and then also several optional fields. For required fields in a road network, we must see an object ID and a shape. These are automatically included in a feature class, so you shouldn't have to worry about these. We must also have attributes for mode type, artificial, and length. These are fields that most likely you will need to add to your network. So mode in this case for us will just be road because we're working with the road network. Artificial will be an integer, and in theory, it can be 0, 1, or 2. But in our network, this will be 0 for all links because all of these links exist. We are not artificially creating any of them. If we were working with multiple modal networks, for example, rail, water, and road, then we would probably want to create an intermodal point feature class, and then we would need to manually add links to the road and to the other networks to connect them to the intermodal facilities. In that case, that artificial code would be 2, but we don't need to do that here. And then length is a decimal number representing the length of each link in whatever default distance units we plan to use in our scenario. So, for example, miles. This is a distinct attribute from this, from an auto-generated shape length attribute that we'll see in the attribute table. Let's go back to our attribute table. So we already have object ID and shape as expected, but we don't have columns for mode type, artificial, and length, so we are going to need to create those. So let's add fields. And our first field is going to be mode underscore type. And the data type will be text. And then we're going to add artificial. Say second field artificial. The data type for this, it's an integer, which we can go with short in ArcGIS. And then length is the last one we're going to add. And this is a decimal number, which we can set to a double in ArcGIS for higher precision. We don't need this one. So then we can exit out of this window and save our changes. And now we're back in our attribute table. And if we scroll all the way over, we see our 3 new fields. They're currently null because we haven't added values yet. So let's go ahead and do that. Start with mode type. If you right click, go to calculate field. And this is in there from when I previously entered it, but if we scroll down to mode type equals, we want this to be road for all features in quotes because this is text. So we're going to let this run and we'll be right back. Great, and we've seen our column has been populated with the road. We're going to also modify the artificial field name. So down here, we said that we want this to be 0 because these are all existing links. So let's apply that one. And now that one's done too. And then we're going to actually exit out of this because length is our last one. And this is based on the actual shape of the individual link. So we're going to have to, instead of calculate field, we're going to calculate geometry. And so for the length field, we're going to calculate length. And then when asked for the unit, we want, in our scenario, we're going to run our scenario in miles. And so we want this length unit to match miles. And in this case, that would be statute miles. This is the standard, quote unquote, miles measure. And then we can leave coordinate system blank because ArcGIS will by default apply the coordinate system that we're already using. Okay, great. And we see that our length attribute has been populated. Again, this is the length of each link in miles. So that takes care of our required attributes. If we go back to the schema, again, we see that there are a lot of optional fields. For example, link type is optional, but highly encouraged to assign a road category to different links. And then FTOT can apply impedances or weights to the cost of transport by link type to encourage or discourage flows on certain parts of the network. For example, you may want to impede the cost of travel more highly on local roads to discourage FTOT from routing freight through neighborhood streets. You can specify the weight for each link in a separate CSV file, and we'll demonstrate that in a few minutes. As another example, dir flag indicates whether a link is one-way or two-way, and if it is one-way, in which direction vehicles can travel. This information is very important in determining a real-world routing solution. Other optional attributes include fields indicating whether a road is in an urban or rural setting, and whether it has limited access, for example, via specific on-ramps to allow for high speed and uninterrupted travel. This information specifically improves calculation of CO2 and other emissions on road. But in this example, we're going to just focus on link type. And we see here that we actually have a road class attribute in the network, which we could possibly use as our link type column. So let's first generate a list of unique values just to see what's included here. If we right click, we can go to summarize. And we're going to summarize road class. We don't particularly care which type of statistic. We just want to be able to see a list of our unique road classes. So let's say OK. Okay, and our tool finished running, and we just see a warning here that there were some null values in this column. That's fine. In FTOT, a missing value just gets assigned the highest weight in your impedances CSV. So let's open our statistics table. And here we see a list of all available road classes, including 2 links that have a null road class. And we see we have these different road sizes and access levels. And actually, we have limited access highway and also a not limited access highway. And these, we could parse these out further if we wanted to create that optional limited access attribute to improve emissions reporting, but we're going to skip that here. So this looks like a great column to use for our link type. Let's go back to our attribute table. We're just going to directly rename this column. We right-click and go to Fields. And so here's the field, and we see the alias was road class, and the actual field name was just class. So the field name is what FTOT's looking for. So if we double-click this, and we're going to rename this link underscore type. We don't have to update the alias if we don't want to. And then we're going to exit, save changes. Okay, and now we're done editing the network. So we're going to set up a separate FTOT input file with the link type impedances next. Let's go back to our common data networks folder. And we see here the default impedance file. Let's go ahead and make a copy of this. So we have something to work from, and we're going to call this MA for Massachusetts road impedances. Let's open this file. In this file, we see a few things. We have a few different columns. We have columns for mode, we have columns for the link type, the weight, or the scalar that we're going to apply to costs associated with each link type, and then just some text notes so that we know what we're trying to do here, what the link types are, and what weights we're assigning. So this was for the default network in FTOT, which is multimodal. We are only working with a road network right now. It doesn't hurt to leave these in here, but it's just not necessary. We're going to delete the modes we don't need. And then we're going to need to update our link types to match the different text values that we saw in road class. And we're going to want to assign weights that make sense. I'm going to clear out these notes because they're not about to be applicable. But the link types in the default FTOT network are based on the functional class. And so roads become smaller as this number increases. And as roads become smaller, we want to more heavily impede them to discourage freight from flowing on those roads. If I pull back my statistics table, I can see the list of all road classes. And we're going to enter these into these columns and assign weights. FTOT is not case sensitive when it comes to reading in link type, so we don't have to worry about the capitals here if we don't want to. We're going to assign our biggest roads the lowest weight and our smallest roads the highest weight. So let's start with, we're going to do limited access highway. Do that as a weight of 1. Multi-lane highway, not limited access. Make these lowercase consistency because it looks nice. We'll assign that a weight of 1.1. Other numbered route is assigned a weight of 1. Let's do 0.2 for that. Major road, arterials and collectors. We're going in order biggest to smallest. We're going to also do a 1.2 for this. So it applies a 20% penalty cost to those roads. Let's do local road next. We'll do a 1.3 for a 30% penalty, and local road without inventory information. We'll also do 1.3. And then optionally, we can include a blank link type and assign a weight. So the null link type will be assigned the maximum from this column. Separately, if you leave a blank link type, this will be a catch-all for any road class that exists, but we didn't specify, it'll assign it a weight of 1.3 in this case. So we're going to save and close. As previously mentioned, the FTOT tools suite includes a network validation tool that lets us just point to the GDB with our custom network, and the tool will run some checks and tell us if the network passes. So we're going to go ahead and run that now. Let's open our command prompt. And then first we need to point to our Python executable, which you can find in the Python 3 environment. Scroll down, python.exe, drag it over, add a space, and then we're going to find the FTOT tools.py file, which is saved under program, tools, FTOT tools.py, and drag and drop that. And hit enter. That'll take a few seconds to run. And while that's going, we're going to go back to where our network is saved. Common data networks. There's our custom network GDB. So in FTOT tools, option 8 is the network validation tool. Enter number. Drag and drop the GDB file with the network to validate. Drag and drop and hit enter. And we see it's running. Okay, and the tool has finished. If we look at what was printed out here, we see it checked whether the GDB contains a feature dataset named network, and we passed. It confirmed that the projection was meters based, and we passed. And then we checked to see which feature classes were present, and a lot of modes, such as rail and water, were not present, but it did find road, which is what we expected. And then for road, it confirmed that our attribute table had the required attributes that we saw in the schema in Appendix B, and so that is also a pass. And then just for convenience, at the end, the tool prints out this network summary, letting us know how many different links are in the network and their total length. So in this case, we have almost 49,000 miles of road network in our custom network. So the next step would be to prepare your scenario files to use your new network. For this tutorial, we've already set up a new scenario directory to test our network. Here we have qs1_custom_road as a variation on the quick start 1 scenario. We open this. These files are already updated and ready to run with our new network, but I'll highlight some key changes in the scenario XML in particular. For a more detailed walkthrough of how to create a new scenario, you can check out our separate Customizing Your Scenario tutorial video linked in the video notes. And first, we see here the base network GDB element. This has been updated with the file path to our custom network GDB. We scroll down a bit. Here's where we can specify default units, and we see our default units for distance are miles. And just a reminder that this unit needs to match the units that you used to calculate geometry for the length attribute in our network. Keep scrolling down. Another element to point out is detailed emissions data. If we had set our network up with those optional attributes specifying rural or urban or limited versus non-limited access, this is where we could enter a file path to the CSV with corresponding emission factors to enable a detailed emissions report. And the user guide provides more information on this functionality if it's of interest. We keep on scrolling down. We'll see the impedance weight data element. We see here that this file path has also been updated to point to our new Massachusetts Road Impedances CSV, which we updated with the road classes that we found in our network. And then next, under permitted mode, so this is very important. We in our GDB only have a road network. We do not have any of these other modes. So we have to set those modes to false, or else FTOT will look for them and not find them and then crash. So road is set to true, the other modes are set to false. And one final item to point out is under artificial links. I haven't actually made any changes here, but these set limits on how far a facility can be located from a network. So how long of an artificial link can FTOT draw to connect that facility to the network. If you are using a relatively sparse network, it's possible facilities could get stranded and not be available for the optimization. So in those cases, you may want to increase the artificial link distance, but that won't be an issue in our very detailed network. And now we're going to go ahead and run our scenario. Open a command prompt. I'm going to drag and drop the batch file and hit enter. And we will be right back when this is done running. All right, now that our scenario has finished running, let's take a look at our maps. First, we have the full network that we prepared for FTOT. And then we can also see the optimal solution using that network. This concludes the video tutorial on how to prepare a custom transportation network for use in FTOT. Please feel free to contact us if you have questions or issues. You can do this through the GitHub repository by logging an issue, or by the email posted on our landing page at volpeusdot.github.io/ftot-public.